So in this session, I'll talk about LU decomposition. It is a factorization. Sometimes decomposition is also known as factorization, right? Factorization. Decomposition means factorization. Okay, keep in mind that. So any A matrix will be given. Okay, you have to factorize in L and U matrix. Okay, what is this L matrix? L matrix is known as we call it lower triangular matrix. Okay, and this U matrix is known as upper triangular matrix, right? So lower triangular matrix, and U is nothing but upper triangular matrix. So you have to factorize this A matrix, okay, into L and U matrix. That is what the situation you have to do. Okay, so how to factorize? Okay, how to factorize? So basically, this A matrix is going to be a square matrix. Okay, and this square matrix has to be factorized in lower triangular matrix or upper triangular matrix, right? Okay, so fine. Yes. So when you can factorize any matrix into L and U, that is also very important to understand, right? That what is that criteria? Okay, what is that condition when you can uh, factorize? Okay, in terms of L and U. Okay, so the very important point is, okay, you have to remember this point. Okay, you can say note. Any matrix will be there whose principal minor, okay, whose principal minor, right? Okay, principal minor uh, must be non-zero, right? Whose principal minor must be non-zero. Okay, if a matrix is given, okay, if a matrix is given, okay, whose principal minors are not are zero, you can say, right? What is the principal minor I'm talking about? Principal minor means the minor corresponding to the principal diagonal, you can say, right? You know, let me take 3 by 3 matrix. Suppose we have got 3 by 3 matrix whose elements are, you can say that A11, A12, A13, A21, A22, right? A23, A A31, A32, A33, right? So if I want to find the principal minor, okay, so what are the principal minor? You can say principal minor is gonna be M11, right? M22 and M33. So they should be non-zero. Okay, this is the first criteria that you have to keep in mind. Okay. What is the first point that you have to notice always is whenever a matrix is given, you can check, okay, whether M11 is 0 or not. If it is 0, then you cannot decompose. Okay, you cannot factorize in L and U, right? That is the primary thing that you have to check, right? Okay. So LU decomposition, this is the first node that you have to remember. Okay, this should not be equal to 0. Okay, I think this is clear, right? Fine. So suppose you have got a matrix, right? A matrix of 2 by 2, you can say 2 by 2 matrix, which is a square matrix. You are factorizing in L and U, right? So you can always express this L matrix as upper triangular matrix. It is nothing but L11, 0, L21, L22. Okay, so in the last session also I have shown you how to express this lower triangular matrix, right? How to express this lower triangular matrix. So L can be written as L11, 0, L21, L22. And you have to find these values, right? What is the value of L11? What is the value of L21? What is the value of L22? So I will be telling you the methods, okay? Some smart method or some direct method, okay, to compute these element of a lower triangular matrix. ठीक है? अब आप जैसे you have considered three elements, in 2 by 2 matrix you have considered there are three unknowns in lower triangular matrix, so you have to only take one unknown in the upper triangular matrix, okay, and diagonal elements should be 1 1, okay, and rest all should be 0, right? So this is the way we have to remember. So this, though this should be u11, right, but u11 here I have taken 1, right? 1 1, this is 0, and it should be u12, right? This is one way. So we have factorized now, right? So A matrix will be given. You can factorize in L and U, or you can say that, or any 2 by 2 matrix is there, right? LU decomposition we are doing. So what we can do here is we can write 1 1, and this is nothing but L2 1, and it is 0, right? This is a lower triangular matrix. Okay, so here only one unknown is there, only one unknown element in the lower triangular matrix. Okay, so what we can do here is, now we have to consider more number of elements which will be unknown in the upper triangular matrix, right? So either way around, right, you can do, and depending upon the question, okay, they will mention in the question what you have to do, right? So accordingly you can factorize, right, any matrices, right? Fine. So आपको यहाँ याद रखना है कि it will be u11, u12, and this is gonna be 0, u21, sorry, it should be u22, right? It should be u22. And you have to find these elements of a lower triangular matrix. You have to find element of upper triangular matrix. That's it. Fine. So I think this is clear for all, right? So what is the first thing? I think nobody might be familiar with that. Okay. Whenever you want to decompose, okay, I have told you many decomposition. I have talked about eigen decomposition, right? Eigen decomposition was also like any matrix is given and you are factorizing that matrix. Okay, I've talked about diagonalization, similar matrices. Okay, so any matrix is there. Okay, like B matrix, you are factorize any A matrix. Okay, A and B are similar, right? So B is what? B is having three matrices, right? Factorized matrices. Okay, so that you have to remember, right? So we have discussed many kind of decomposition, right? So here matrix decomposition. Okay, so ये एक स्पेशल है, और एक और टॉपिक है which is known as single value decomposition, which is important for you can say for all the branch of engineering as well as data science and AI, right? Because each year you will find some new concept in the gate examination, so you should prepare for the worst, right? So fortunately in data science and AI they have mentioned that topic. Fine. So Chatri, till this point everything is okay? Like you understood how to start with LU decomposition? So we will talk about direct method, okay, and then we'll talk about some smart methods, right? So there are different methods. So first of all, let me talk about direct method. Okay, direct method. What we know always, yes. Suppose LU decomposition questions are given. Okay, so we always go for direct method, and it takes a lot of time. For 2 by 2 matrix it's fine, but for 3 by 3 matrix it might become cumbersome, right? So suppose A matrix is given and you have to decompose it, or you have to factorize it. Okay? See, decomposition and factorization both are same word, right? Please remember. So A equal to LU. Okay, now you can write them as like L110, L21, L22, and you can write this as 1 U12 0 1, right? Now what is the direct method? Direct method is just you can multiply these two matrices, L and U matrices, just you can multiply, right? And then what you can do, you can equate with A matrix, and equate the element. Okay, the two matrices is going to be equal. So you have to use the concept of equality of the matrix. Okay, equality of the matrix means what? Element wise they should be same, right? Equal. Okay, two matrices are equal. So after multiplication, what will be the size of the matrix? A matrix is 2 by 2 matrix. Okay, A matrix is 2 by 2 matrix here, right? After this is also 2 by 2 matrix, this is also 2 by 2 matrix, right? So after multiplication, direct multiplication you are going to do. So if you multiply this, so if you multiply L110 here, so you will get L11 here only, and then if you multiply with this, okay, so you will get here L11 U12. Just multiply these two matrices. Okay, that is called the direct method, right? आप डायरेक्टली मल्टीप्लाई कर सकते हो. आई थिंक anybody can multiply these two matrices, right? It's not a big deal. Okay, so you L11, okay, understood. Please remember. Then you can say u L21, and here you will get L21, u12, okay, u12, L21, okay, u12, and then plus L22, right? L22. So these are the element that you are going to get after multiplication. Then what you can do, you take a matrix, you take this guy, and then what you do, compare and find what are the things, what are the element that you have to compute. L11, L21, L22, and U12. These are the four unknown that you have to determine, right? Okay, so I think this is clear for all, right? But you have to always make sure that the principal minor, right? Principal minor should be non-zero. You have to always make sure that if principal minors are not zero, right? Principal minor means, you know, you have to take a11, corresponding to that you have to find the minors. A11 means first row and first column and first row you have to suppress, and remaining is going to be giving you the minor of the A11, right? That is. अच्छा, how to compare? Yes, how to compare means element wise. देखो, जैसे एक मैट्रिक्स मान लो दिया हुआ है, how to compare? Very good question, right? देखो, suppose you have got A B C D, or after multiplication you got a matrix. You can say this is a matrix like, you know, L11, L you know, this is nothing but L11 U12, right? And this is L21, L21, and then U12 plus L22, right? So suppose you got after multiplication this kind of a matrix, right? Now how can you say that these two matrices are equal? I think I have discussed in the beginning of basics of matrices, right? So how can you say these two matrices are same, right? ये 2 by 2 का matrix होना चाहिए. First of all, size should be same, then only you can compare. Now L11 can be what? Chhatri, can you see what will be the value of L11? What will be the value of L21? बताइए जल्दी fast. From here you can say that clearly it is visible. L11 is A, L21 is C, L11 U12 is going to be B. So you can say that U12 is nothing but B by A. Okay. Yes. So this is how we compare, right? It's a very simple, yeah, fine. All values you can find out. Okay. Fine. Now you can compare with this, and you can put all these values. You will get that. Right? So this is the, this is the direct method. Okay, and you know, I don't prefer this method, okay, because this method takes a lot of time, lot of effort, right? And I think it does not take your brain as well. You know, anybody can compare if the sizes of, if the matrix size is same, okay, anybody can do it. But as the order of the matrix increases, more number of unknowns comes into picture, so it becomes really difficult to use direct method. Okay, what you can do here is, let me take one example, right? Let me take one example and try to use this direct method, right? So that you guys can understand. Okay. So suppose any matrix is given, A matrix, right? And you can say that we have got 2 1 4 minus 1, right? 2 1 4 minus 1. What is the size of the matrix? Size of the matrix is 2 1 4 minus 1, right? So you can find the principal diagonal. You can say principal diagonals are non-zero, right? I mean principal minus are non-zero. You can see if you suppress first row and first column, so m11 is going to be -1 and m22 is going to be 2, right? So they are non-zero, right? It's fine. So you can factorize, right? So what you can do, you can write this as LU, right? Stands for L110, L21, L22. You have to remember this, right? If you're writing L matrix like this, so you have to write this matrix, upper triangular matrix like this, okay? This is the first step that you can do. Next step is what? You can just multiply. So after multiplication, what you are going to get? You will get L11, L11 U12, L21, right? L21 U12 and then plus L22. Now what you do? You compare with 2, 1, 4 minus 1. Okay, so clearly from here you can see that L11 is going to be 2, right? L21 is going to be 4, right? I think this is clear. And U12 is going to be 1 by 2, and then L21 U12 plus L22 is going to be, L21 is what? L21 is 4 into 1 by 2, right? Okay, 4 1 by 2 plus L22 you don't know, which is equal to -1. So guys, you can find out this goes 2 times, right? So L22 is what? L22 you got here is -3. Okay, I think this is clear. Understood this, how to use this direct method and find out these unknown in the upper triangular matrices. So you can say that your A matrix becomes what? You can write here A matrix is nothing but L is 2, 0, 4, and then L22 is -3, and U matrix is 1, 0, and what is this U12? That is 1 by 2. See how beautiful. So from here to here, from here to here. अच्छा 1 by 2 कैसे आया? Fine. Yeah, it's a very good question. See, what you do, you take this guy and you compare with this. So, L11 is 2, U12 will be 1 by 2, right? Understood? I directly written it because I thought of, I thought you might be able to understand this, yeah? Because see, here L11 times U12 is equal to 1. So what is the value of L11? L11 is 2, right? So U12 is gonna be 1 by 2 because you take this guy like 2, you take this side. समझ आया क्या ये चीज? आपको ये समझ आ गया ना ये कैसे आया? ये तो सिंपल काइंड ऑफ मैनिपुलेशन है, राइट? Fine. So let me move ahead. Try to avoid this method, okay? Sometimes you can use it, but most of the time we have to use some other method, right? So you can use this method as well. I'm not saying that, I'm not against. If you are having a lot of patience as well as you are interested in long step, okay, fine. So let me talk some sort of smart methods, or you can some sort of shortcuts, right? Smart methods now. So suppose you have got A matrix. A matrix is nothing but same answer we'll get, okay? Whatever answer we have got here, by going for by computing by solving this LU decomposition by direct methods, ठीक है? आपका सेम आंसर आने वाला है by using this smart method as well, ठीक है? Okay guys, so please remember these points. These points are sometimes important for all, right? So So what you have to do here is, please remember, okay, so first of all, you suppose any matrix is given. I will take the same matrix, that is 2 1 4 minus 1, right? 2 1 4 minus 1, right? 2 1 4 minus 1. It is important, right? It is important. So you have got 2 1 4 minus 1, right? So earlier, you see what we have done, it was very simple, right? In fact, you can also write this A matrix as, right? You can also write this. See, I will talk about smart math, okay, very soon. But you can also write this A matrix as uh, L times U, which was, you can say that this is nothing but 1 1, right? And this is L 2 1, and this is 0. And you can say that this is U11, U12, and 0, U22, right? You can also find this okay, decomposition, right? So either you express A matrix like this, or you express A matrix like that, okay? आपको जैसा क्वेश्चन में पूछा जाएगा वैसा आप एक्सप्रेस कर सकते हो, ठीक है? तो ऐसा कुछ नहीं है कि मतलब बोथ आर पॉसिबल, राइट? बोथ आर पॉसिबल, ठीक है? दोनों में सेम लेबर लगना है, सेम अमाउंट ऑफ एफर्ट यू हैव टू पुट, राइट? अंडरस्टूड? तो ये सारी पॉइंट्स हैं जो यू हैव टू कीप इन माइंड. एंड so in smart method, what we will do here is we will we will try to get this A matrix, and then here you have to remember some of the operations you have to apply, right? So what we will try to do here is we will try to get from A matrix, we will try to get from A matrix, we will try to get some matrix L, right, initially, okay? From A matrix we have to get L matrix, okay? Understood? From, or you can also get upper triangular matrix also, right? So from A matrix we will get lower triangular matrix. So how to get this lower triangular matrix, that is a question, right? So I think everybody knows that how to get lower triangular matrix, okay? So by any means you have to get lower triangular matrix, or you can also get upper triangular matrix, right? I will tell you. So I think everybody knows the echelon form, right? How to apply echelon form, how to get the echelon form, okay? By applying some operations, okay? So suppose this matrix A is given, so you have to make this matrix in terms of lower triangular matrix. So lower triangular matrix कैसा दिखता है? You know, the upper diagonal element should be 0, right? So how can we make this as upper triangular matrix? We have to make this as 0, right? I mean, right? So all other elements should be okay, right? So what we can do here is we can yes, okay, or see, A matrix will be given, you have to get into L matrix, or you can say that we will also go for A matrix will be given, so you can also get U matrix, right? Okay, so these are the two steps that we will do, okay? Either you prefer one first journey from A to L or A to U. So how we will get that? That is the main question, right? The question is how we are going to get yes, R1 is R1 plus R2. That you can do. Perfect. Yeah. So let me do, okay. And then how to get U matrix, right? So it's a very simple method. If you know, just wait. Wait and watch. I'm just telling you, right? So initially we'll see how to get L matrix, okay. 1 minute, perfect. So you will be able to understand. So this smart method is only useful, okay, so that you guys can get very quickly anything, right? Chalo. So A matrix is this 2 1 4 1. So first of all you have to check whether a m11 is what? M11 is nothing but -1 here, and you can say m22 is nothing but 2. Both are non-zero, right? Both are non-zero. So this is the requirement for LU decomposition, right? This is the requirement for LU decomposition, right? Okay. Now what we have to do, we can get I will go to next page, right? So you have to get from A matrix to L matrix, right? Okay. So how to get this A matrix to L matrix? You have to apply column operation. You have to apply column operation, not the row operation. Okay. Remember this. This point is important. If you want to get A matrix to L matrix, so what you have to do? You have to multiply column operations. You have to multiply always column operations, right? Understand? But how to apply column operations, right? That is also very important. So suppose you have got any identity matrix, okay? So if you apply, remember, suppose any identity matrix is given, and if you apply column operation here, so you will get E, okay? And E is known as elementary matrix. इसको क्या बोलते हैं? Elementary matrix. Okay. So I is given, you can say I is given, identity matrix is given, you have to apply column operations, so you will get elementary matrix, right? And finding elementary matrix is important in this case, okay? So keep in mind this, I is given, I is what? Identity matrix, you know, diagonal elements are 1 1 and other elements are 0 0, right? So non-diagonal, you can say off diagonal. I is going to be I will become elementary matrix when you will apply column operation, right? Okay, that is very important. So the way you will get after applying column operation L matrix, whatever column operation you have applied on A, you have to apply same on I. ठीक है, अभी देखो कैसे करते हैं. ठीक है. So what we will get is, suppose we got A matrix is there, okay, and you got L matrix, right? So you can say that L matrix you got, so you can multiply A times E, okay, A times E equal to L, okay, first of all. Then you can say that A is going to be L times E inverse, right? L times E inverse. How we got L times E inverse? देखो, what you can do, you can multiply, post multiply E inverse, okay? So here you can say that E inverse equal to L E inverse. What is this? E times E inverse? A equal to L E inverse, right? So this E inverse, see, L matrix already you got, but what is this E inverse? If you compare with L A equal to L U, right? तो आप क्या करोगे यहाँ पर U equal to यहाँ से क्या आ रहा है? Clearly it is visible, that is E inverse, right? Okay. So you got L, but you can also get U by taking inverse of E, right? And this is nothing but, U is nothing but what in this case? Inverse of elementary matrix. ठीक है. I will show you everything step by step, don't worry, right? अभी हम करने वाले हैं, ठीक है. तो आपको एलिमेंट्री मैट्रिक्स कैसे मिलेगा? फ्रॉम द आइडेंटिटी मैट्रिक्स. अब आइडेंटिटी मैट्रिक्स में व्हाट काइंड ऑफ कॉलम ऑपरेशन यू हैव टू अप्लाई? तो द वे यू अप्लाइड कॉलम ऑपरेशन ऑन ए, जो भी कोफिशिएंट लिए हो, मल्टीप्लाई किए हो, स्केलर को मल्टीप्लिकेशन किए हो, राइट, द सेम यू हैव टू परफॉर्म ऑन द आइडेंटिटी मैट्रिक्स. ठीक है सर. एल टाइम्स ई इनवर्स कैसे हुआ? देखो, ई इनवर्स को आप बोल सकते हो आई. ठीक है, मैंने क्या किया, पोस्ट, अच्छा हाँ नहीं आया समझ में, फाइन फाइन फाइन. अब ये आ जाना चाहिए, ये चीज आपको पहले बताई जा चुकी है. देखो मैं आपको बताता हूँ. जैसे आप क्या करो, कोई मैट्रिक्स ए है, राइट, तो उसको आपने ए ई इक्वल टू एल के फॉर्म में लिख दिया, ए इक्वल टू एल के फॉर्म में लिख दिया, राइट. अब क्या करो, आप पोस्ट मल्टीप्लाई करो ई इनवर्स से, पोस्ट मल्टीप्लाई ई इनवर्स. तो पोस्ट मल्टीप्लिकेशन का मतलब है आफ्टर दी, okay, after this you multiply here, okay, and after this you multiply here, right? So what is this? This is nothing but I. You can say that A equal to L E inverse. फिर आप समझ आ गया क्या आपको? सी यू टेक एलिमेंट्री मैट्रिक्स, उसका इनवर्स मल्टीप्लाई करोगे so you will get identity matrix, right? So this is A. Now if you compare with, yes, fine, A equal to LU, so L तो आपको पता ही है, but what is this? You can say U is going to be inverse of the elementary matrix. Now how to get this elementary matrix is the main question, right? It's a very important case. ठीक है. So let us take first of all let us see how to get that ठीक है, तो ये important है, understand. Fine. So let me take now the question again, right? Suppose A matrix is given, which is nothing but 2 1 4 minus 1, 2 1 4 minus 1, right? 2 1 4 minus 1 is the given matrix, right? It is important. Okay, it is important. Okay. So 2 1 4 minus 1. Now can you apply the column operation on this so that you can get L matrix? तो आप क्या करो, कॉलम ऑपरेशन लगा सकते हैं यहाँ पर. तो कॉलम ऑपरेशन कैसे लगाओगे? हाउ यू विल गेट कॉलम ऑपरेशन इन दिस केस? 2 1 4 minus 1, राइट? सो कॉलम ऑपरेशन अगर आप लगाते हो तो यस, कॉलम ऑपरेशन का मतलब ये होता है कि आपको क्या करना है, यू टेक दिस एज अ पिवट एंड यू कैन मेक इट जीरो. कैसे आप जीरो कर सकते हो? कॉलम C2 को कॉलम C2, so you have to understand guys, fine. So what we can do, so how to get elementary matrix? Keep in mind this, right? So see, A to L you have applied some column operation, right? So the same column operation you have to apply on I. Okay, like whatever coefficient you have chosen, right, in case of A matrix, to reduce it to lower triangular matrix. Okay, आपको सेम कॉलम ऑपरेशन यूज करना है along with the coefficients, along with that scalars, right, that you have chosen. And ये समझ आया कि आपको छत्री? तो from I matrix to E matrix you will get here. Then you have to find E inverse, right? And this E inverse will be U. तो आपका A क्या हो जाएगा? A is equal to L times E inverse, or you can say LU. परफेक्ट. चलो अब आगे चलते हैं आगे. तो let me take one more question so that you can understand. एक क्वेश्चन और लेते हैं तो आपको समझ आएगा. one more example you can say. And suppose we have got A matrix which is 2 2 4 9. अभी हम 2 by 2 की मैट्रिक्स ले रहे हैं क्योंकि दे आर वेरी सिंपल, राइट? अब देखो, याद रखना, A मैट्रिक्स इज देयर. सबसे पहले आपको चेक करना है माइनर प्रिंसिपल माइनर्स. ओके ओके, दे शुड बी नॉन जीरो. नाउ यू सी 2 9, yeah, they are non zero perfectly, right? So diagonal element itself are going to be a principal minor, right? So यहाँ पर आपका नॉन जीरो है, तो आप डायरेक्टली इसको क्या कर सकते हो? यू कैन डिकम्पोज इनटू LU, राइट? So first of all what you have to do, you can apply on A the column operation, right? So C2 करना है, ठीक है, C2, okay, minus C1 directly you can do now, right? You can directly subtract, okay, C2 minus C1 because now 2 2 same. ठीक है, यहाँ से कितना आ जाएगा? A इक्वल टू, ये तो सेम रहेगा, पहला कॉलम सेम रहेगा. सी यू आर अप्लाइंग ऑन फर्स्ट, okay, you are taking the reference of first, okay, you are multiplying by scalar, so keep first as a same. You can consider this a pivot column, right? तो आप इसको 0 बोल दो और ये 5 आ गया. दिस इज L मैट्रिक्स. but there should be one more matrix. Okay, remember this matrix is E inverse, or you will also call it U, right? So guys, this matrix you can directly write. अब देखो वो सब करने की जरूरत नहीं है, वट एवर वी हैव डन, है ना। दो आपका प्रोसीजर वाइज आपको वही करना है, लेकिन हम ये ई इनवर्स डायरेक्ट लिख सकते हैं। कैसे, देखो इसका कोएफिशिएंट क्या है C1 का, देखो C1 का कोएफिशिएंट क्या है छत्री, प्लीज टेल मी व्हाट इज द कोएफिशिएंट ऑफ C1। आपको पता है कि दिस इज अ L मैट्रिक्स। इन केस ऑफ U मैट्रिक्स you write always this is what, this is U12 which is not known, right? What is the value of U12 that you can directly find out? कैसे, आप कॉलम ऑपरेशन में जाओ और C1 का कोएफिशिएंट देखो क्या है। C1 का कोएफिशिएंट क्या है बताओ। C1 का कोएफिशिएंट है -1। आर यू एबल टू सी छत्री? C1 का कोएफिशिएंट क्या है, स्केलर मल्टीप्लिकेशन इवेंट से, दैट इज -1, राइट। -1 का अपोजिट क्या होगा, 1 होगा। यू कैन जस्ट टेक पॉजिटिव ऑफ -1, राइट, सो इट विल बी 1, तो इसकी वैल्यू 1 आ जाएगी। तो आप डायरेक्टली बोल सकते हो कि a इक्वल टू व्हाट, 2045 एंड यहाँ पर 110 एंड दिस इज 1, दिस इज द आंसर। हाँ, तो जो U12 की वैल्यू होगी उसको माइनस ऑफ माइनस लेना है हमेशा, ठीक है। तो आपको डायरेक्टली आपको आइडेंटिटी मैट्रिक्स से फिर वो सब नहीं करना पड़ेगा, डायरेक्ट आप लिख सकते हो, ठीक है। ये समझ आया क्या आपको? सी whatever E inverse we have got here, I can show you, see क्या करना है। जैसे I आपके पास दिया हुआ है, that is 1001. Now you have to apply here what you have to apply C2 में C2 minus C1, राइट। तो ये कितना हो जाएगा 10, ये तो 0 ही रहेगा, सॉरी इट शुड बी -1 हियर। नाउ दिस इज E, नाउ यू हैव टू गेट E इनवर्स। E इनवर्स कैसे निकालते हैं आप इसको, सॉरी दिस शुड बी 1, इंटरचेंज कर दोगे तो 1 1 ही रहेगा, ये 0, इसको माइनस कर दो बस, खत्म। ये तो इंस्टेड ऑफ डूइंग लाइक दिस, आप डायरेक्टली, क्योंकि आपको पता है अपर ट्रायंगुलर मैट्रिक्स में एक ही अननोन होगा U12, राइट। 1 1 आप लिखो 0, और U12 के लिए जस्ट माइनस ऑफ द कोएफिशिएंट ऑफ C1, राइट, परफेक्ट। अब देखो एक, you can also do like this, what you can do, suppose second way of doing, suppose A equal to LU है, right, A equal to LU है, so first of all what we can do, we can reduce A to U, ठीक है। अभी तक हम लोग क्या कर रहे थे, we were reducing A to L, अब क्या करेंगे A to U करेंगे, reduce करेंगे A to U, right, what we have to do, we have to reduce it to A to U, okay। तो आपको पता है कि हाउ कैन वी ऑब्टेन दिस अपर ट्रायंगुलर मैट्रिक्स फ्रॉम द ए मैट्रिक्स, कैन यू टेल मी? आप जैसे एक्लॉन फॉर्म में आप एलिमेंट्री ऑपरेशन लगाते हो, द सिमिलर वे यू हैव टू डू हियर, राइट। हाउ टू ऑब्टेन, क्वेश्चन इज हाउ टू ऑब्टेन U, ओके, फ्रॉम A, ठीक है। सो आप क्या करोगे, रो ऑपरेशन, यू हैव टू अप्लाई रो ऑपरेशन। You have to apply row operation, guys, ठीक है। What operation you have to apply? You have to apply row operation, A to U journey, ठीक है। तो आप A मैट्रिक्स ले लो, ठीक है। तो आपके पास क्या रहेगा, A to U you have to go, so A matrix you write here, you leave this gap, okay, and here you will get U matrix here, this is U matrix, this will be U matrix, you can say U11, U12, 0, U22, you will get U matrix, okay, after applying row operation, and this matrix is nothing but the elementary matrix that you will get, okay, this matrix is going to be E inverse, E inverse, fine. So this is nothing but 1 1 0 L12, okay. तो आपको कैसा मिलेगा, A equal to E inverse U, so now your E inverse is nothing but L this time in this format. ठीक है. Okay, I hope this makes sense. ठीक है. So what you can do here is, आपके पास A matrix है. Okay, A matrix है. You got what? U matrix, right? Now what you can do, you can just multiply by E here. E times A equal to U, right? Suppose EA equal to U, you got. Now what you can do, you can pre-multiply E inverse, right? Pre-multiply E inverse. Okay, so E inverse E A equal to E inverse U, right? So this is A equal to E inverse U. ठीक है, ये याद रखना. So earlier it was L times E inverse. Now you are getting E. Like depending upon your, depending upon the question, right? Okay, that is very important. ठीक है, you can see the question और आपको पता चल जाएगा कि अपर ट्रायंगुलर में ज़्यादा अननोन है कि लोअर ट्रायंगुलर में ज़्यादा अननोन है, उसके अकॉर्डिंग आपको लगाना है. तो अगर आपको A से U जाना है तो रो ऑपरेशन, A से L जाना है तो you have to use column operation, and same column operation you have to use in identity matrix so that you can get elementary matrix. ठीक है. तो मेरा कहने का मतलब है कि सपोज आप रो ऑपरेशन लगा रहे हो टू ऑब्टेन यू, so you have to apply same row operation on I so that you can get E, right? Understood? I think this is clear. Fine. So let me take one question here so that what is that question? Suppose A matrix is given which is 2 2 4 9. You have to factorize into LU which is nothing but 1 0 L2 1 0, sorry, L2 1 like this. ठीक है. Sorry guys, you can correct here. I think we have done L2 1 you should write here, right? क्योंकि ये लोअर ट्रायंगुलर मैट्रिक्स होना चाहिए. ठीक है. We took upper triangular matrix itself. ठीक है, याद रखना. That should be lower ना. Lower means what? Off diagonal, above the diagonal it should be 0 and below the diagonal it should be non-zero, right? So please correct that. That was not intentional mistake. So LU equal to what? 1 0 L2 1 1, right? और जब यहाँ पर एक एलिमेंट अननोन है तो आप यहाँ से ले लो कि अपर ट्रायंगुलर मैट्रिक्स में ऐसा कुछ होगा, U11 U12 0 U22. तो जब ऐसे इस फॉर्मेट में हमें डिकम्पोज करना है ए मैट्रिक्स को, तो आप क्या करोगे? रो ऑपरेशन लगाओ, सिंपल सा रो ऑपरेशन लगा देते हैं सर. सो ए मैट्रिक्स में हम रो ऑपरेशन लगाएंगे. यू कैन से दैट यू जस्ट टेक दिस गाय एज अ पिवट, राइट? सो R2 में लगाना है तो आप क्या कर दोगे? R2 minus 2 times of R1, right? So you keep this guy, this space, I mean just keep this space. Okay, there should be some space guys. Okay, you write like this. Okay, please remember, है ना? A equal to leave some space, right? Leave some space. Okay, understood? Please remember this, leave some space. So I'm going to leave this space. You can say this space is nothing but 1 1 0 L2 1, right? You can write this matrix, I don't have any problem. And this is nothing but what? Now what is the value of L2 1? That we can directly find out. ठीक है, ये कितना हो जाएगा? 2 2, ये एज इट इज लिखना है, 0 हो गया, ये 5 हो गया, ये आ गया. Have you got the upper triangular matrix? Okay, I think this is upper triangular matrix, right? छत्री, you can get upper triangular matrix ना डायरेक्टली. आप कैसे, है ना? अब ये L21 क्या होगा? L21 का मैंने आपको बताया था कि जो इसका कोएफिशिएंट है -2, इसका माइनस ऑफ माइनस ले लो तो L21 यहाँ से कितना आ जाएगा? 1 0, ये 2 हो जाएगा, ये 1. तो कैन यू टेल मी विच मेथड इज मोर इजी? कौन सा मेथड ज्यादा सरल है? ये मेथड, शॉर्टकट मेथड और स्मार्ट मेथड और आपका डायरेक्ट मेथड? कौन सा मेथड इजी है? देखो मैंने क्या किया, L21 निकालने के लिए जस्ट इसका कोएफिशिएंट जो था -2 को -(-2) लिख दिया बस। या कि आप ऐसा भी कर सकते हो कि if you want to get this E, this is nothing but E inverse, remember. तो I है, I is nothing but 1 0 0 1. Now apply the row operation, -2 times of R1, so you will get E. Okay, E. So here it will be 1 0 only, and this is going to be -2, right? And this will be 1 only, right? Now you have to find E inverse. तो आपका E inverse कैसे निकलता है? Everything is gonna be same if you interchange them, right? क्योंकि इसका डिटर्मिनेंट तो 1 ही आएगा, तो यू नो इट विल बिकम G21. ये देखो, okay, so this method is powerful, right? This method is powerful that you can get. देखो 2x2 मैट्रिक्स को तो डिकम्पोज आप कर लोगे. लेट अस टॉक अबाउट 3x3 मैट्रिक्स, हाउ टू डिकम्पोज दैट. ओके, so example of 3x3, example of 3x3 मैट्रिक्स, राइट? आपका साइज ऑफ द मैट्रिक्स है 3x3, तो आप ए मैट्रिक्स चूज करो. ए मैट्रिक्स, A matrix is nothing but what? 1 2 0 1 3 1 0 1 3. ठीक है, A matrix आपका दिया हुआ है. Now you have to convert in, you have to decompose into LU matrix. So it's your choice, right? I mean, according to the question, you have to go ahead, right? So what you want, how you want, right? So there are two formats, okay? Like L can be expressed like this: L11 0 0, L21 L22 0, L2 L31 L32 and L33. I hope this makes sense. यहाँ पर number of elements which are unknown in L, right? So better to go for column operation. Column operation लगाओ इसमें, ठीक है, इस केस में. और आप क्या करो यहाँ पर, 1 1 1 you put 0 0 0, U11 U12 U13, you can say this is U1 U21 U22. It should be U23 actually. There are 3 elements which are not present, right? Which are not known, you can say. Otherwise all these U12 U13 U21 can be obtained just by looking at the column operation. Okay, it's a very simple process. I will show you, right? अब आप क्या करो, सबसे पहले you just apply column operations, right? Okay, column operations, ठीक है, just to get from A matrix to L matrix. तो आप क्या करो, apply column operation. So on 2, okay, we are going to apply on this and on this. Already it is 0, so you don't have to apply anything, याद रखना. Okay, I think this is clear. So what you can do, this is the first column. Okay, first column I am applying. I want to make this element 0. You can take this as a pivot and make this guy as 0. You can take this as a pivot and make this guy as 0, right? You can take this as a pivot, okay, and you don't have to make it 0. केवल आपको ये 0 करना है, ये 0 करना है. Okay, आप off the diagonal, upper the diagonal, you have to make it 0, right? So पहला ऑपरेशन क्या है, C2 minus 2 times of C1, right? Okay, I think this is clear, right? What you can do, A से L आएगा. You can write this as 1 0 0 0 1 1, and these elements I'm gonna write directly. ठीक है, याद रखना. ये कैसे आएगा, C2 ऑपरेशन से. So your first column is gonna be same 1 1 0, right? 1 1 0 is going to be same. Now you subtract by multiplying, so it becomes 0, it is 1, and ये 1 ही रहेगा. ठीक है. I think this is clear, right? I think this is clear. Okay, now you can apply one more column operation since it is 0 here, right? So you have to make this guy as 0, right? So what you can do directly, what you can do, It is very important, right? So you remember this is nothing but 0 1 3, right? आप क्या करो, आप just you take this, right? You earlier we took this as a pivot, now you take this as a pivot, okay? And subtract directly. So here you can apply C2 on C3, C2 minus C3, right? Okay, understood. So you will get next matrix as, let me write in the next page because here it will be little. I'm just going to copy this matrix and so A matrix has been decomposed into 1 1 0. It will be same. This is also same. Now it becomes 0. Already it is 0. This is 0. And you're multiplying, you're directly subtracting, so this becomes 2. So you got all the values here. You got all the values, right? You got all the values. Now the question is, this is 1, this is 1, this is 1. It should be 0 0 by default. Now what is the value of this? What is the value of this? What is the value of this? That you have to determine. Okay. So u12 will be what? u12, right? So what is the first operation that you have applied on column 2? जो आप कॉलम 2 में अप्लाई किए हो उसका कोएफिशिएंट यहाँ लिखना है. कॉलम 3 में जो अप्लाई किए हो विथ रिस्पेक्ट टू कॉलम 1, आपको फर्स्ट रो कॉलम की एंट्रीज हैं, राइट? दे कैन बी टेकन एज फर्स्ट कॉलम एंट्रीज, राइट? तो आपको पहला क्या 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 लगाया था, यहाँ देखो. C2 was applied like this. C2 equal to C2 minus 2 times of C1 with respect to C1. Okay, remember you applied column operation on C2 with respect to C1, तो आपको ये वाली वैल्यू मिलेगी, ये वाली. ठीक है, यहाँ पर मैं रेड कलर से हाईलाइट कर देता हूँ. इसका जो माइनस ऑफ माइनस आएगा, इट विल बी 2. ठीक है, इट इज गोना बी 2. नाउ have you applied any operation on column 3 with respect to column 1? Please छत्री बताना. Have you applied any column operation on column 3 with respect to column 1? आप देख सकते हो यहाँ पर. See, I haven't applied any. Only one column operation that we have applied. Okay, because it was already 0, guys. If it is 0, so we don't have to apply any kind of column operation. तो उसको भी आप बोल सकते हो कि ये क्या होगा, 0 होगा. ठीक है. See, if you haven't applied any column operation, तो आप 0 लिख दो. ठीक है. Now come to next. Now you have applied on C3 with respect to C1, right? Sorry, with respect to C2, right? आप इसका वैल्यू कैसे निकालोगे? ये जो कॉलम ऑपरेशन लगाया था, कौन सा वाला, ये कितना है? C3 minus C2. So you are applying column operation on C3 with respect to C2. Okay, so what is that coefficient? This is nothing but 1. ये आंसर है. देखो कितना फास्ट आप आंसर कर सकते हो, राइट? हाउ फास्ट यू कैन आंसर द क्वेश्चन. समझ आया क्या ये एलयू डिकम्पोजिशन का गेम क्या है? It's not a tough topic, it's an amazing topic, right? If you are studying under, like if Dheeraj sir is teaching you, so it becomes more easy, more interesting, right? आपको ही समझना है. So A matrix can be decomposed, or you can say factorized to L and U. Okay, L and U, fine. So I hope this makes sense, right? So this is nothing but E inverse, and this is nothing but LE. So E inverse is U here, right? Okay. I think this is clear for all, right? So this is what the LU decomposition, guys. The LU decomposition is over in this case, right? So there is nothing more than that. Now you can try question PYQ. You try. Okay, so some of the point that you have to remember. See, we can try this question. We can also try this question. Okay, we can. This is L. This is U. Now you can take L as less number of element will be unknown. U. Okay, so you can first try A to U journey, right? Let me solve that also. सेम एग्जाम्पल। तो आप ए मैट्रिक्स ले लो। ए मैट्रिक्स क्या दिया हुआ है? योर ए मैट्रिक्स दैट इज 1 -3 0, ये 0 दिया है 1 3 2 -10 एंड दिस इज 2। ठीक है, अब आप क्या करो इसको L के फॉर्म में। L इज नथिंग बट दिस 1 1 1 एंड दिस L2 1 L3 1 L3 2, ये सबको 0 कर दो। फाइन, नाउ you write the L matrix, right? Now you can say that U11 U12 U13 0 U22, okay, U23 0 0 U33। तो ये L है, ये U है, right? So first of all what you have to do, number of elements are more here, like unknowns, right? So you first try to make your journey from L to U by applying some sort of row operation, right? It's nothing but an echelon form you have to obtain, right? So so it's a easy journey, right? Okay, आगे की बात करना है अगर, तो what you have to do, so we can apply here the row operation. You can apply, let me take this guy separately, so that we can apply the row operation. So from here clearly you can say that you will not apply any kind of operation on R2 with respect to R1, ठीक है, याद रखना। तो आप डायरेक्टली बोल सकते हो कि इसकी जो वैल्यू आएगी L21 की, L21 की वैल्यू 0 होगी। L21 की कोई वैल्यू मान लो पूछता है इन दिस क्वेश्चन, व्हाट इज द वैल्यू ऑफ L21, राइट? L21 की वैल्यू क्या आएगी? तो यू आर नॉट अप्लाइंग एनी काइंड ऑफ रो ऑपरेशन, राइट, विथ रेस्पेक्ट टू फर्स्ट रो, ठीक है, क्योंकि ऑलरेडी इट इज 0, राइट? सो यू विल नॉट अप्लाई एनी ऑपरेशन, ठीक है। L21 की वैल्यू कोई पूछेगा, ऐसा क्वेश्चन दे दिया, पूछ लिया L21 की वैल्यू क्या होगी, कुछ लोग होते हैं घबरा जाएंगे, राइट? हम तो डायरेक्ट आंसर देने वाले लोग हैं, राइट? तो कहां पर आपको a को u में रिड्यूस करना है, इन व्हाट सिचुएशन यू हैव टू रिड्यूस a टू lower trigonometrics, that decides your question, right? So the way your question is going to ask, okay, you have to examine, right? ऐसा नहीं है कि डायरेक्टली सर ने बता दिया अब हम ऐसा कर रहे हैं, जो क्वेश्चन में पूछेगा आपको वही करना है, बस आपको टेक्निक सारी पता है, डायरेक्ट मेथड, you know smart method given by the right? So how to compute elementary matrix, उसका इनवर्स निकालना, ठीक है, लेकिन मैंने आपको इनवर्स निकालना डायरेक्ट बता दिया है, तो इट्स अ वेरी सिंपल प्रोसेस, ठीक है। तो आप क्या करो यहाँ पर, जस्ट टेक दिस गाय एज अ पिवट। तो R2 में कोई ऑपरेशन नहीं है, R3 में R3 में R2 में कोई ऑपरेशन नहीं, मतलब L21 विल बी 0, डायरेक्टली मैं यहाँ लिख सकता हूँ, ठीक है, नो ऑपरेशन। R3 में लगाना है तो R3 कैसे लगाओगे, 2 टाइम्स ऑफ R1, राइट? तो यहाँ से आप बता सकते हो कि व्हाट इज L22, L2, या नॉट L22, L31 you can say, right? What is L31? L31 will be 2 only, ठीक है, L31 is going to be 2, you can find out from here directly, right? तो आप जो भी ऑपरेशन लगाते हो तो L के एलिमेंट निकालना तो बहुत ही इजी है, ठीक है। आई होप दिस मेक्स सेंस, इट्स अ वेरी इजी प्रोसेस। नाउ so you have got A matrix as, I mean, okay, you can just keep this guy some space here. This is nothing but 1 -3 0, and ये कितना हो गया, 0 1, we haven't done anything here, 0। अब इसमें 2 से मल्टीप्लाई किए हो तो -6, एंड इसमें ऐड किए तो -4, राइट? You multiplied something and then you will get 2 here only, right? Fine, now you have to take this as a pivot, right? and then इसको 0 बनाना है, तो आप 4 से मल्टीप्लाई करवाओगे एंड ऐड कर देना, राइट? तो क्या करना है यहाँ पर फॉर दिस, नेक्स्ट आप R3 में लगाना है विथ रेस्पेक्ट टू R2, राइट? सो R3 देन प्लस 4 टाइम्स ऑफ R2, राइट? So ये this will give you the value of, what is L, you can say that what is that unknown L32, yes, L32 की वैल्यू क्या आ जाएगी? छत्री, can you tell me what will be the value of L32? सर इसको तो पहले लोअर ट्रायंगुलर करना है ना? नहीं, देखो, दैट्स व्हाट आई टोल्ड यू, राइट? आई हैव ऑलरेडी शोन यू, आपको पहले मैंने शो कर दिया है कि कब आपको एल लोअर ट्रायंगुलर में करना है, कब आपको अपर ट्रायंगुलर में करना है। मतलब ए टू एल कैसे करना है, देखो, कॉलम ऑपरेशन आप कब लगाओगे? जब आपको ए मैट्रिक्स को पहले आप एल में कन्वर्ट करना चाहते हो। यहाँ पर हम क्या करना चाहते हैं? पहले ए मैट्रिक्स को अपर ट्रायंगुलर मैट्रिक्स में कन्वर्ट करना चाहते हैं। क्यों ऐसा करना चाहते हैं? क्योंकि हमारा जो रिक्वायरमेंट है ये है, दिस इज माई रिक्वायरमेंट नाउ। अगर आपको इस फॉर्म में ए को डिकम्पोज करना है, किस फॉर्म में? इस फॉर्म में A00 L21 like this, more number of elements which are unknown in upper triangular matrix। तो आपको क्या करना है? A2U फाइंड करना है रो ऑपरेशन लगा के, ठीक है? छत्री, आपको ये समझ आया ना? और आप A2L कब करोगे? मतलब A2L कब फाइंड करोगे? कॉलम ऑपरेशन यूज करोगे वहां पर, जब थोड़ा सा ये प्रैक्टिस में डाल लो, राइट? ये बहुत इंपॉर्टेंट है ना? ये उन लोगों के लिए नहीं है जो फॉर्मूला बेस्ड हैं, जिनको कॉलम ऑपरेशन नहीं आता है, जिनको रो ऑपरेशन लगाना ही नहीं आता है, जो केवल रट लिए हैं, पीपल हु हैव मार्क्ड अप कॉन्सेप्ट, राइट? सो उनके लिए नहीं है ये, उनके लिए जो स्मार्ट पीपल हैं, है ना? समझ आया ना? हु वांट्स टू डू समथिंग इन देयर लाइफ इन मैथमेटिक्स एंड कंप्यूटिंग। तो A इक्वल टू दिस, राइट? तो यहां से आप L32 की वैल्यू बता सकते हो क्या होगी? L32 का मतलब क्या है यहाँ पर? कि यू आर अप्लाइंग रो ऑपरेशन ऑन थर्ड विथ रेस्पेक्ट टू 2। सो ये जो कॉफिशिएंट आएगा रो ऑपरेशन में, व्हाट इज L32? L32 विल बी -4। मैंने बताया इसका माइनस ऑफ दैट कॉफिशिएंट यू हैव टू टेक, राइट? सो ऑलरेडी यू गॉट L मैट्रिक्स, राइट? सो L मैट्रिक्स तो आपको मिल चुका है। यू कैन से हियर 1 0 0। What is the value of this? 0 1 0। and what is the value of this? 2 -4 1। L मैट्रिक्स तो आपको डायरेक्ट मिल जाता है। okay, L matrix you got already। now you are applying this on this। okay, so keep as it is। तो आप ऐसे ही लिखो फर्स्ट वाले को, you just apply here। so 1 -3 0 0 1 3 0। अगर आप इसमें 4 से मल्टीप्लाई करवाते हो, ऐड करते हो, इट बिकम 0। 4 3 जा 12, राइट? एंड 2 से ऐड करोगे तो ये 14 आ गया। बस आंसर आ गया, है ना? यही आंसर है। आप बोल सकते हो दिस इज 1 0 0 0 1 0 2 -4 1। ये आपका ई इनवर्स है विच इज इक्वल टू L एंड दिस इज U। समझ आया क्या ये चीज बताना फास्ट? तो मैं एक बार समराइज कर देता हूँ, याद रखना हमेशा। एंड बिफोर आई वाइंड अप द सेशन, समरी LU डिकम्पोजिशन का, राइट? summary of decompose LU। okay, please remember guys, these are important points that I'm telling you। ठीक है? देखो, अगर मान लो A को आप ऐसे फॉर्मेट में, ठीक है, A को आप LU में कन्वर्ट कर रहे हो, बट यहाँ L का जो फॉर्मेट है कुछ ऐसा है, L210 L22 L, sorry, L, 1 minute guys, let me write properly। तो अगर मान लो ऐसा है L L12 L11 0 L21 L22 एंड U आपका 110 U12 है, राइट। तो आप क्या करोगे इसमें A to L फाइंड करना है, दैट इज कॉलम ऑपरेशन। ओके, एंड I to E कैसे लगाना है, कॉलम ऑपरेशन से ही। ओके, तो योर A विल बी इक्वल टू L टाइम्स E इनवर्स। फिर इससे आपको E इनवर्स निकालना पड़ेगा, लेकिन आपको यू डोंट हैव टू डू एनीथिंग, राइट, यू कैन डायरेक्टली फाइंड आउट। ई इनवर्स निकालना बहुत सिंपल है, मैंने आपको बता दिया, जस्ट टेक द कोफिशिएंट अपोजिट साइन ऑफ द कोफिशिएंट, राइट। तो आपको याद रखना है कि विथ रिस्पेक्ट टू व्हाट ऑपरेशन दैट यू आर अप्लाइंग, व्हाट ऑपरेशन, राइट, व्हाट कॉलम, व्हाट on which column you are applying operation with respect to what column, what is the reference column। और अगर आपका ये जो है आप ऐसा लिखते हो 1 1 L21 it is 0 and your upper triangular matrix has more number of unknowns, तो आप क्या करोगे A2 अपर ट्रायंगुलर मैट्रिक्स में कन्वर्ट करना है बाय रो ऑपरेशंस। ओके, and then you have to go for I to E, here again you have to apply row operations, and then you A equal to what, A equal to E inverse U, you can find E inverse from here, but why to waste time, why to waste time to find E inverse and all, I have told you the trick to understand। I hope this makes sense to all, right? So LU decomposition is over guys, समझ आया क्या बताओ। नाउ द नेक्स्ट टॉपिक्स विल बी व्हाट, देखो क्या क्या टॉपिक मुझे अभी कवर करने हैं, दोस थिंग्स आई एम गोना लिस्ट। ओके, एंड आई थिंक वी हैव डन ऑल द टॉपिक्स, राइट। अब कुछ टॉपिक्स हैं जो मुझे बताना है, ठीक है, क्या क्या टॉपिक्स बताना है मैं आपको बताता हूँ। टॉपिक्स टू बी कवर्ड, राइट। देखो एज पर डेटा साइंस एंड एआई, हालांकि सारे ब्रांच के लिए ये इंपॉर्टेंट है, नॉट ओनली फॉर कंप्यूटर साइंस, फॉर ऑल ब्रांच ऑफ इंजीनियरिंग, राइट। सो टॉपिक्स टू बी कवर्ड में क्या क्या टॉपिक्स अभी हमें करने हैं, राइट। अगर आप डेटा साइंस सिलेबस देखोगे तो उसमें पार्टीशन मैट्रिक्स है, उसकी प्रॉपर्टीज है ना। वी हैव टू मोर फोकस ऑन लाइक ऑर्थोगोनल मैट्रिसेस। अब देखो ऑर्थोगोनल मैट्रिसेस को हम लोग रोटेशन मैट्रिक्स ही बोलते हैं, आप कभी रियलाइज नहीं करते हो, बट मैं हमेशा फील करता हूँ जब भी हम कोई मैट्रिक्स को किसी वेक्टर के साथ मल्टीप्लाई करते हैं, तो अगर उसमें रोटेशन आता है और स्ट्रेचिंग आती है, राइट, रोटेशन आता है मतलब वो एक रोटेशन मैट्रिक्स है, और ऑर्थोगोनल मैट्रिक्स एक ऐसा मैट्रिक्स होता है जिसमें रोटेशन 100% आने वाला है। ओके, तो हमें बात करना है नॉर्म्स ऑफ अ मैट्रिक्स की, ठीक है, नॉर्म्स ऑफ मैट्रिक्स, ये टॉपिक कोई नहीं पढ़ाता है, नॉर्म्स ऑफ अ मैट्रिक्स, राइट। नॉर्म्स ऑफ अ मैट्रिक्स इंपॉर्टेंट है, हो सकता है इस साल कोई गेट में क्वेश्चन आ जाए, मतलब इन 2024। नॉर्म्स ऑफ अ वेक्टर सबको आता है, ठीक है, नॉर्म्स ऑफ अ वेक्टर कैसे निकालते हैं, लेंथ ऑफ द वेक्टर। उसके बाद नॉर्म्स ऑफ अ मैट्रिक्स हमें डिस्कस करना, जैसे नॉर्म्स ऑफ अ वेक्टर वी हैव डिस्कस, देयर वर मेनी नॉर्म्स, राइट, L2 नॉर्म्स, इन्फिनिटी नॉर्म्स, ओके, फ्रोबेनियस नॉर्म्स, बहुत सारे नॉर्म्स हैं हम लोग देख चुके हैं, यूक्लिडियन नॉर्म्स, राइट। और उसके बाद नॉर्म्स ऑफ अ मैट्रिक्स के बाद वी विल टॉक अबाउट वी हैव टू डिस्कस सिंगल वैल्यू डिकम्पोजिशन, सिंगल वैल्यू डिकम्पोजिशन, quadratic forms, okay, and positive definite matrix, Based on my presence of mind, I'm telling you, right? I will take a look again in the data science syllabus, and then I will tell you. But this is what I am thinking right now. Okay, these topics I have to cover. तो क्वाड्रेटिक फॉर्म्स एंड पॉजिटिव डेफिनेट मैट्रिक्स किसको बोलते हैं, ठीक है. एंड आई विल गिव यू मोर रिफ्रेशर, राइट. कैसे देखो, एवरीथिंग इज गोना बी सेम, राइट. लाइक आई टोल्ड यू, ऑर्थोगोनल मैट्रिक्स आर ट्रीटेड एज रोटेशन मैट्रिक्स. अब रोटेशन मैट्रिक्स आप किसी मैट्रिक्स को बोल सकते हो. जिस अगर कोई भी मैट्रिक्स है उसको अगर आप मल्टीप्लाई करवाते हो किसी किसी वेक्टर के साथ, तो अगर उसमें रोटेशन आता है तो मैट्रिक्स रोटेशन मैट्रिक्स हो जाएगी, राइट. अंडरस्टूड. दैट यू हैव टू रिमेंबर. So quadratic form and the positive definite matrix. Single value decomposition is one of the very important idea, right? This is we call it popularly SVD. ये बहुत singular value decomposition और single value singular, okay. Singular value decomposition, right? SVD, okay, not single, right? Because sometimes what I always think is like, your matrix is decomposing into a single value, right? So like lambda and all we got. So singular value decomposition, SVD, quadratic forms, positive definite matrix, right? And there are some miscellaneous topics, okay, topics related to, okay. This decomposition is applicable on non-square matrix as well. Non-square matrix as well. ये जो singular value decomposition है, it is also applicable on non-square matrix. So you can also decompose non-square matrix. अभी decomposition का मतलब तो आपको पता है, समझ में आ रहा होगा, right? It is nothing but a factorization. आपको factorize करना है, okay? तो यहाँ पर दो ऑर्थोगोनल मैट्रिक्स रहेंगी, बीच में एक क्या रहेगा, डायगोनल मैट्रिक्स रहेगा, ठीक है, याद रखना. एंड okay, like you will multiply two matrices which are orthogonal matrices, and in the mid there will be one. So we'll see how to get that, and topics related to basics of matrices, right? Special matrices that we like, we can talk about idempotent matrix, Hermitian matrix, okay. और बहुत सारी चीजें हैं कॉम्प्लेक्स, अगर एलिमेंट्स हैं किसी मैट्रिक्स के, है ना, तो we'll discuss them. So in fact you can now expect कि we will conduct 2 to 3 sessions more on this matrix. Okay, so I hope this makes sense, guys. This is enough for today. Okay, we'll meet in the next session. Okay, so Chhatri, it is okay. I mean, everything is okay, like you have understood all the points, what is LU decomposition and all. तो आपको हमेशा फोकस करना है मैट्रिक्स डिकम्पोजिशन में. ओके, मैट्रिक्स डिकम्पोजिशन, आइगन डिकम्पोजिशन, राइट. ओके, singular value okay, singular value decomposition. Okay, in fact when you talk about similar of the matrices, right, similarity of a matrices, there also you decompose B matrix into you always decompose B matrix into P A P inverse, right, like this. So what is this? It is also factorization now. You are factorizing this B matrix into this, right? Understood. So everywhere this decomposition means factorization, याद रखना. Decomposition means factorization, okay. So matrix decomposition का मतलब है कि you can decompose into a single value, right? Matrix can be decomposed. So matrix can give you rotation, matrix can give you stretch, right? अगर आप किसी matrix को किसी vector के साथ multiply करते हो तो you can get so eigen decomposition is done for the sake of you can say for the sake of pure stretch, right? अगर किसी वेक्टर में प्योर स्ट्रेच आता है that is called the eigen decomposition. Pure stress का मतलब that pure stress will be the eigenvalue, right? That pure stress is going to be the eigenvalue, and corresponding to that eigenvalue, whatever vector you will get will be known as eigenvector. ठीक है, तो eigen decomposition में हम eigenvalue and eigenvector we get, okay? But suppose any matrix is there जहां पर you can say suppose any matrix is there, right? So suppose ये vector आपका u vector है and this vector is v vector, right? So if you take a matrix and you multiply u, you got, if a matrix you are operating on this u vector, you got v vector, right? ठीक है, तो अगर मान लो इस v वेक्टर का लेंथ भी बढ़ गया है, कैसे स्ट्रेचिंग, तो यहाँ पर रोटेशन तो हो गया, रोटेशन काइंड ऑफ रोटेशन यू गॉट, तो रोटेशन हो रहा है, मतलब वो मैट्रिक्स किस टाइप की मैट्रिक्स होने वाली है, इफ रोटेशन इज देयर दैट मैट्रिक्स इज द ऑर्थोगोनल मैट्रिक्स। तो हमारे जो मैट्रिसेस हैं व्हाट वी हैव स्टडीड लाइक ऑर्थोगोनल मैट्रिक्स, राइट? ऑर्थोगोनल मैट्रिक्स को हम लोग क्या बोलते हैं? ऑर्थोगोनल मैट्रिक्स की डेफिनेशन क्या होती है? यू नो दैट ऑर्थोगोनल मैट्रिक्स की डेफिनेशन क्या होती है? व्हाट इज द डेफिनेशन ऑफ ऑर्थोगोनल मैट्रिक्स, राइट? So A transpose and the A inverse when they become equal, right? So that is known as orthogonal matrices, right? I think that everybody knows, right? मतलब अगर आपका A ट्रांसपोज है और A इनवर्स है, राइट? अगर ये दोनों बराबर होते हैं तो हम लोग ऑर्थोगोनल मैट्रिक्स बोलते हैं। आप ऐसा ही बोल सकते हो कि A ट्रांसपोज और यू कैन से A ट्रांसपोज E। अगर आपको आइडेंटिटी मैट्रिक्स मिलता है, इट मीन्स व्हाट? what is the meaning of this? Meaning is it is orthogonal matrix, right? और orthogonal matrix को हम लोग क्या बोलते हैं? जब भी आप A को A ट्रांसपोज से मल्टीप्लाई करवाओगे, you will get I matrix. So this kind of matrix is known as rotation matrix. Rotation, it will always give you rotation. तो आप देख सकते हो कोई आजकल क्वेश्चंस आएंगे पक्का, इन द गेट एग्जामिनेशन दे विल आस्क क्वेश्चंस, ओके? इन डेटा साइंस एआई दे विल डेफिनेटली आस्क, मतलब आपके कंप्यूटर साइंस में भी आ सकते हैं, किसी ब्रांच ऑफ इंजीनियरिंग में आ सकते हैं, राइट? तो आप प्रॉपर्टी ऑफ आइगन वैल्यू, आइगन वेक्टर भी सीखो। रैंक ऑफ द मैट्रिक्स मैंने आपको बता दिया, बहुत सारी डेफिनेशन रैंक की हैं। वी हैव टॉक्ड अबाउट सिस्टम ऑफ लीनियर इक्वेशंस, ओके? हाउ टू सॉल्व सिस्टम ऑफ लीनियर इक्वेशंस, राइट? बहुत सारी चीजें हम लोग डिस्कस किए हैं। तो सिस्टम ऑफ लीनियर इक्वेशन कैसे सॉल्व करते हैं, व्हाट आर द फॉर्म्स ऑफ सिस्टम ऑफ लीनियर इक्वेशन, क्या क्या सॉल्यूशंस होते हैं, राइट? तो जो जो टॉपिक्स हो गए हैं उनको आप अच्छे से कर लो, राइट? और बेसिक जितना भी बचा हुआ है, 2-4 टॉपिक्स, व्हाट एवर टॉपिक्स इज देयर आई विल डिस्कस, राइट? सो टेक केयर, विल मीट इन द नेक्स्ट सेशन, राइट? ओके गाइज।